Hi, I'm Tina Huang. I'm co-founder and CTO of Transposit, where we build an API composition platform. And this platform is really a culmination of my various experiences building platforms and services at companies like Google and Twitter, but also building very early APIs for the application frameworks at Apple for OS X. And so many of you probably have never heard of this term API composition, but my hope is by the end of this presentation, you'll have some better understanding of it. So it should come as no surprise to any of you being here at Nordic APIs, but APIs are everywhere. And this is largely driven by the increase of SaaS, which has been a huge boon to business productivity, but it's been really hard on application developers. And this is primarily because data is moving out of sources that you control and locked behind APIs. As Jeff Bezos famously said, and I realize I'm not the first person at this talk to mention Jeff Bezos, with the 2-pizza rule, individual teams shouldn't be larger than what you can feed with 2 pizzas. And so organizations internally, well, they are also moving towards various API strategies, not only to decouple their systems from a technical and engineering perspective, but also to allow teams to operate more independently. We also see increasing numbers of clients. We're no longer talking about just web and 1 or 2 mobile devices, but a plethora of mobile clients we need to support, as well as the uptick of things like chatbots and all of the different IoT devices. And so companies are starting to look at API-first approaches for actually building their products. And over time, we're starting to see all applications are effectively platforms. And that means your application needs to be able to absorb data from all these different data sources, as well as take the data that you're creating and push them to other platforms. So here we are. We have this forest of APIs. These APIs are both internal and external to our companies, which is great. We have higher and higher levels of abstraction, and developers have all kinds of superpowers. You know, we have APIs for emailing and SMS, and you can build super powerful DevOps tooling on top of platforms like CircleCI, AWS, and Slack. But that means over time, fewer and fewer applications are actually built from scratch. We rarely see applications that look like just a single server on top of a single database. And so our job as developers is increasingly about connecting and combining APIs into either new applications, but quite often, yet more APIs. Unfortunately, connecting and combining these APIs rarely looks like snapping together various Lego blocks. APIs are super powerful, but we all know using APIs is kind of a pain in the ass. Each API is a unique snowflake. I mean, who here has spent more time reading some nitty-gritty documentation on how to use an API just to get it to work? I saw at least one hand out there. That's because APIs often reflect how the service owner is thinking of their data, and more often than not, how their data infrastructure is laid out, and not how you, as a consumer of those APIs, really wants to use that data. For example, what data they've chosen to cache and index in their service, well, that's going to dictate what API calls are even available to you. Another manifestation that we often see is what's called the N+1 problem. And you're probably really familiar with this. It's when what should really be a single API request to fetch a list of items accidentally becomes N+1 requests, as you're having to do that follow-up request to get more details for each item in that list. And another example of this is pagination. You know, when you want to get 100 results and you fetch 25, and then the next, and then the next, and then the next. And we often talk about pagination as if it's one single mechanism. But in practice, there's tons of different mechanisms that all represent pagination. The most incredible example I personally witnessed of this is the Slack API. Slack has, I kid you not, 5 different pagination mechanisms, all for just their API, sitting side by side with each other. And who here wants to guess how they might solve this problem? You guessed it. Probably a 6 pagination mechanism, one that's going to rule them all. The same lack of standardization also affects authentication. But at least with auth, we're starting to see some consolidation with OAuth 2. But unfortunately, we're going to be dealing with legacy auth for a very long time. And even with OAuth 2, there's still quite a bit of variation between different implementations. And so once you start to factor in things like rate limits, retries, and everything we've talked about here, your code to connect and combine all of these different APIs is starting to look like a convoluted mess. And the real problem here is we're not talking about just the complexity within a single application. We're really talking about the complexity of interactions between services that need to communicate over the network. And so that means that all application developers in this API ecosystem need to know about distributed computing. Just pause and think about that for a second. They need to be able to code against unreliable networks. They need the code to be resilient against long latencies. They need to be sure they aren't overwhelming the underlying systems and invoking various rate limits. And only your most sophisticated developers and ones with extra free time on their hands will get around to doing things like optimizing for tail latencies. So we all know that there's this massive developer shortage out there. And what we've really done here is raise the bar to what it actually takes to be an effective developer in this new ecosystem. And so collectively, we need to look at new strategies to lower that bar and enable more application developers to be more effective. So I told you I would introduce this concept of API composition. At Transposit, we consider this work of writing all of this glue code to connect and combine data together. We call this API composition. And the reason that we spend so much time thinking about this problem is the number of APIs and services, they just keep on growing. We've all seen this. And unfortunately, writing the code to connect and combine actually increases with complexity at an exponential level the more APIs and services we have. And over time, as we're building all of these different API compositions, we start to see the same compositional logic being implemented across different parts of our org. And with this developer shortage, it's important that we actually maximize the utility of this code that we're writing. But as we discussed just a second ago, this code is often really convoluted and tangled. And once you combine that with the fact that APIs are ever evolving and ever changing, this code can become very, very fragile and difficult to maintain. And so finding ways that we can share this code will help us to amortize the maintenance costs across multiple developers. We also see user benefits to consolidating this code. We've all experienced this as consumers of applications where, depending on which part of the product and organization you're talking to, you get a very different view of the data. There's also performance and reliability reasons for not just wanting to share this code, but actually centralize this code in a centralized service. For example, when you need to introduce things like caching, not just to make your API calls perform better, but to not overwhelm those downstream dependencies. You might want to collectively cache these results and actually share that cache across multiple clients. And if your downstream dependencies, if they have rate limits, this might actually be more than just an optimization, but a necessity, making sure that one client can't blow through the rate limits of another. I talked to this company once who their main product depended on the Salesforce API. And yet, at a completely different part of their organization, they had a contractor that was building some sort of Marketo and Salesforce integration. And this contractor blew through the rate limits, actually taking down their production service. So once we think about all of these cases, having a centralized place for things like caching and rate limiting, it can have real benefits to your final product. So what do we do about this? We all know that we live in this crazy API ecosystem, and now we understand that it's important that we are able to build this compositional logic in order to build the applications that benefit our business, and that we want to be able to share this compositional logic not just to move faster, but also to provide better user experiences. But what's exactly the best way to share this logic? Well, assuming that your organization already has some sort of mechanism for publishing and sharing artifacts, your most lightweight mechanism is probably just using libraries and modules. But unfortunately, this won't solve a lot of the problems that we just discussed that you get from having a centralized service, such as fixing centralized caches. But the other big problem with libraries and modules is there's a complete lack of governance. You know, one of these trending topics that we've been hearing about at this conference. Over time, your organization's probably going to end up with many, many versions of the same library, all deployed in prod. And there's unfortunately then no easy way to deprecate out old versions. At a minimum, this will result in disjoint logic across your different products. But even more importantly, if and when there's some sort of security problem that you need to patch, there's not really a good way to upgrade this library throughout all of your different products. We've all seen horror stories of this. I don't know how many of you remember the left pad incident, but it was just 11 lines of JavaScript code. And the author of this library decided to unpublish it on NPM, resulting in thousands of projects breaking all across the internet. Another example is that event stream library. It was briefly hijacked for some sort of Bitcoin siphoning, and the hacker quickly patched it up to cover the tracks. But when something like that happened, how did you actually make sure that no one in your org was still running this vulnerable code? These are pretty extreme examples that I'm talking about that all involve public libraries, but these kinds of things happen all the time internally within your org, where very subtle changes to a library on one side can have massive consequences to products on another. So then we have this trend towards microservices. And this is great because we now have a centralized place for doing all of these things like caching and rate limiting and deploying out security fixes as we need them. But microservices are actually a pretty heavyweight solution for a lot of problems. Each one requires a developer to allocate new infrastructure, to configure deployment, to set up monitoring, to be able to scale this code in these different microservices. And most importantly, you actually need someone in your organization who's willing to both own and operate this microservice. At Twitter, I saw this all the time, where developer productivity would slow way down anytime we asked the team to move their code out of our monolithic Ruby on Rails app and into its own separate microservice. And that's because the responsibility of the developer went from, how do I codify this small piece of business logic and build my feature, into basically everything about how to run and operate a microservice. So if your organization has something like a handful of microservices, you're probably doing this right. You're probably using microservices to encapsulate internal databases, to encapsulate core infrastructure. But I've heard of many organizations that have hundreds, even thousands of microservices within their org. And in this case, I'm going to guess that you're actually using microservices not just for this core logic to your company, but also to encapsulate these pieces of compositional logic. And I'd like to ask you all to consider whether or not there might be a lighter weight alternative for these cases. So most recently, we've seen a move to this third path called serverless. But what exactly is serverless? I'm going to argue it's a little bit of a misnomer because with serverless, there's still servers, just servers you don't have to run or manage. But at the core with serverless, it's a really cool concept and architecture. It's about allowing the developer to focus just on their code with zero of the housekeeping. So I really prefer the term that's also used for this, function as a service. And there's tons of benefits to this sort of architecture, but there are still underlying costs, some of which were noted in the previous keynote. For instance, you have to think about routing requests to the right code through something like an API gateway. For many platforms like AWS Lambda, there's something called cold start latency that affects not just the initial startup of your Lambda, but also every time they need to spin one up in order to scale. And unfortunately, this latency is something that you have almost zero control over. And finally, because with stateless functions, you don't have any ability to store state within the function itself, there's extra work in managing state in these external services. But I'd like you to consider an expanded definition of what function as a service could be. And really at the core, that means let the developer focus on their code and let the platform just do all kinds of magic. And now if you combine this concept with the more specialized task around APIs and API composition, then suddenly you can enable this platform to do all kinds of heavy lifting for you around APIs and composition. So what would a function as a service for API composition look like? Well, I'd like to tell you at least how we've thought about it at Transposit and share with you some of the learnings that we've had. So similar to other functions as a service, we want to allow the developer to focus on their code. But instead of having these independent functions that are all decentralized in this crazy ecosystem, we decided to centralize them in a platform to enable better sharing and collaboration and discovery, as well as to provide governance. We also have built-in mechanisms around APIs and compositions that lets the code run in the context of a data pipeline, which removes many of the challenges in building stateless functions. We make caching and rate limiting trivial to protect those downstream dependencies. And we treat versioning and branching as a primitive so that teams can remain agile. But critical to this layer is really pulling all of the tedium into the platform. And so we think that what's imperative here is really creating a higher level abstraction so that the developers can just express the intent of what data they like to retrieve, and let the platform think about all of the mechanism around how to actually perform those API calls and do this compositional logic. At Transposit, we've chosen to use SQL as this higher level language, but really any sort of abstraction that allows the developer to focus on the how or on the what of what data would I like to get, and lets the platform think about the how of how am I actually going to execute and retrieve that data will work. So this problem is accelerating. We have more and more APIs every day. And whether or not you think about how many APIs you're using in the past, how many APIs you're using right now, and just imagine how many APIs you're going to be using in the future, you need to start thinking about this compositional problem. So even if you're not ready to adopt some sort of API composition platform or build one internally, there's a few things you can do right now. For one, you can adopt internal standards around authentication and pagination. It's been spoken about many, many times, but adopt specifications like OpenAPI. Function as a service, I think, is a thing, and it's here to stay. So if you're using the public cloud, look at your vendor for what options are available, and there's a number of choices on-prem. And again, another theme. APIs are products. Please manage them like products and think about their user experience. As an industry, we've been talking about this API lifecycle for quite some time, and it encapsulates everything from building your APIs to making them easier to maintain and use as a consumer. And so I really urge you to start thinking about API composition as the next part of this strategy. Thank you very much.